Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to day 33 of NL Math Man. Yes, good afternoon, Mr. Math Man. Thanks. Thanks, Bert. Good to see you. Happy Thursday. We're here, keeping it down, holding the fort. Another day of another day of teaching and correcting, right? Not just math. I mean, I'm teaching and correcting a lot of science too, and whatever whatever my students come up with, I suppose. But another day of streaming math because that's the more intensive one, right? Yeah, it's the one where I can work through the workings on stream, have it be a little bit like we're back in class, right? So for today, so you got a rather nice picture here behind me of this was me. My parents took this one after I just parked the skidoo after having driven into the cabin. Um, yeah, I believe I was. Let's see, what did I do on this trip? I think I drove out to. Is Monday a holiday? Yes, yes. Monday is indeed a holiday. Monday is May 24. I mean, it's May 18, right? But it's May 24 because that's what we says it is, right? It's Victoria Day holiday is what it really is. I mean, May 24 is just a nickname for it, you know. Although maybe I'll do some of the above. I don't know. I don't know. There is still snow on the ground in lots of places, but this ain't skidooing weather for this May 24. Um, my parents are actually out at their cabin now. They went in, I don't know, a few days ago or whatever. Um, so yeah, apparently it's the woods roads to get in there are rather difficult to navigate because there's still a lot of snow down, but it's all like sloppy and not really very good for skidoo either. So it's springtime. This like long sort of dragged on spring that just never ending. Spring is long and full of terrors. It just is not conducive to getting in the woods to the cabin very much, right? Because the road is like an old woods road that was put in there for harvesting timber, right? And that's not it's not maintained in the winter. It's not used currently for woods. It is used actually. There's a gravel pit up near there now. The gravel pit is still being used, and I don't think it's being used over the winter because that'd be a bit weird, but maybe it is. My parents said that it was plowed and maintained into a point into where but that's only like a quarter of the way in or so. Right? So if I go out there, if I take the trek out tomorrow after stream, maybe I'll be loading up the VK, the old the Yami, the Yami there that I'm on top of, because you know what the Yami is, right? Yami boy, it's just skidoo with a Yamaha sticker on her, right? But I was on the front that day, and coolers on behind, right? I believe in this picture I had just driven out to a last year May 24th was on a Monday, but the holiday was the Monday 7 days before. I'm not sure why. That's a bit weird. I thought if actual 24th of May was a Monday, then that actual day was the holiday. Or maybe it's a weird technicality where like it has to be the Monday before May 24th. So if May 24th is itself a Monday, it doesn't count as being before itself. I mean, I guess that's weird. I assumed that like this setup this year would be as long before as it could possibly be. But maybe I'm wrong about that. Maybe it is. It has to be before the Monday before the 24th of May. Yeah, that is weird. Yeah, in this picture, I think, pretty sure I had just driven out the road to like a gas station slash restaurant slash store and bought some supplies. There's a very nice store, only a 20-minute or so skidoo ride from the cabin that has homemade fries. They do fish and chips and meat pies and turkey dinner and jigs dinner and all the important stuff, right? And they do homemade bread. And you can buy like some rudimentary groceries there, like potatoes and beer, right? The important stuff. The two main food groups, and gas, of course. So I'm pretty sure at this point I had the cooler filled with beer and that box on the back that you see there that Dad made. That sort of box with the axe or whatever. Pretty sure that had some takeout in it. I think it had some fries that were a little bit worse for wear after the drive. They might not have Still weren't super warm or crispy, but you do what you can, right? And of course, Flurry and Smokey had to come out and greet me because I was gone. I was gone maybe an hour. I might have been gone, right? That's they for all they knew. For all they knew, I was gone away out somewhere having loads and loads of fun, and they were missing it, right? And that's always stressful on doggies when someone leaves and they think, hey, that person's having fun and I'm not there, right? I assume that's what they think. That would make the most sense to me for what they think. Um, yeah, I was going to talk a bit about that box that was on the back of the Skidoo and all that, but you can't really see the all the details of it. You can see there's an axe, a little hatchet there stuck to the back of it. That's very useful. There's like a come along down inside it and all that stuff for when you get stuck, as you do, right? Because that stuff happens. There were snowshoes fastened to the side of it as well, but for whatever reason in this picture it's not there. But anyway, you know, allows you to store a little bit on the Skidoo because that's not she ain't a racing machine, boys. This is not not out doing like winter targa or whatever the I don't know what's the name of some sort of like Skidoo race in Newfoundland. I don't know. That's a working machine, right? That's for getting groceries and hauling wood as we do, right? Anyway, it's enough rambling about winter. Seeing we're kind of not in winter anymore, sort of. Spring is weird, but something that's not weird is math, right? Good segue. That was boy, look at that. This is why I'm a professional. I'm not a professional streamer, really. Professional, I don't know. Anyway, but it's segues like that set you apart from the norm, right? Uh, yeah, it is good fun in the winter. Albert Einstein, that's true. I'm gonna launch in and out in a second to Math 2101A Unit 2 review. I was asked a few questions for that one specifically. I'm going to do. I think there was a question off of a recently submitted activity that I wanted to get to, and then there were a few that I was asked about specifically. So I'm going to bring up a few, do the example that I was asked about, and then a few like that from the textbook. After I get done with that one, I'm going to introduce Math 3102B. Now, Esther, that is the course that you probably haven't started it yet because you just got ready to go with it today. But this is going to be a really important bit for you with that course. I'm going to talk you through how to use an online calculator to do some of the work because this is one of the two courses that actually you're supposed to get. Whoa! Ah, look at that! Look at that! Getting. Whoa! That's cool. I didn't know that would work. That's awesome. I'm gonna try to try to make my chroma key so this works so I can keep doing this. But if it's clear, why can't I see Peter's face behind it? Why do I see the skidoo and not Peter's face? Oh my god, it's a portable hole in time. Um, that's what I would think, right? Like if you put it in front and it was transparent, you should see you should see my face behind it, right? No, instead it's a portal to the winter. There we go. But only when it's over here. Real talk, it's because it's reflecting. It's reflecting the blue light from the on light on my webcam, which makes it a similar color to the tarp-ish thing that I have behind me. Anyway, but yes, Esther, to get back to what I was saying before I got distracted by shiny things or transparent things. Um, you need one of these for this course. This is one of the ones that loans out these calculators, but of course you're not going to be required to have one at home, but you are going to still be able to complete the course. And the way you're going to be able to do it is with an online calculator. Now, of course, your guide doesn't mention that because your guide wasn't made for, teaching at home. This kind of thing was adopted quickly and we're just sort of running with it, right? It just so happens that the program and um, the instructors and whatever are reasonably able to adapt to the online system. But the resources that we have were not made for online. So instead of using the calculator, you're going to use an online one that I'm going to show you. Now, there's a lot of different online ones with a lot of different features. I found one that's pretty reasonable, I think, to what you'll need in the course. So, yeah, make sure to. I mean, I guess if you're here, you're already watching, and if you're not here, you're not going to hear me saying this. So, right, sort of maybe a little bit of a waste of breath. So how about I just go on now to doing some of the questions that I wanted to get to in 2102B, 2101B, 2101A. My lord, I'll get it right one of these days. It doesn't matter. It doesn't really matter if it's right or not. Like, it's only me. It's only me that's concerned if I'm getting it right. Right? At least the names of the courses, I mean. Okay, so this is Math 2101A, Unit 2. Right? And this is going to be question 1D off the assignment for that unit. Boy, the camera's a touch off today. Come on, come on, come on. There we go. That's better. There we go. That's pretty good. That's pretty good. Okay. So for 1D, we have rather intricate looking little diagram here with a whole bunch of lines going on. At first glance, it looks, I mean, it does look a bit complicated at first, but, you know, to just reiterate the same thing that I'm always saying, this really is nothing new. All this is the same stuff that you've seen a bunch of times, just with a heck of a lot of it all mashed up together once. Right? And what else do we need to know? We need to know this is parallel with this. Right? Then we need to know that this is 35 degrees. This is T down here. This is 76 up here. S down here. R over here. And 108 over here. Okay. So now we need to start determining, well, what of these can we figure out? Right? Well, we know we can figure out R right off the bat. R is easy, right? Because we know that a straight line makes 180 degrees, right? So we know that this arc right here, one that I'll do it in red to show that it was new, that one, oh, let me check, sorry, distracted by something. Okay, that one is going to be 180, which means R is going to equal 180 minus 108. So we know that R is going to equal 72 degrees. Okay? Right? That's pretty straightforward. Now, we know that this angle, sorry, this line up here, we know that that line there is parallel with this one. And remember, when we make a Z shape like that with these lines, so two parallel lines, and then the same line crossing both of them, we know a lot about those angles now. So we know that this angle here and this angle here are going to be equal, right? So this is 35. We know that this is going to be a 35 up here, like that, because of alternate interior, right? So now once we know that, we can get the angle T, of course, right? And the angle T then is going to be 180 minus 35 and minus 76, right? So 35 and 76 is 111, and 180 minus 111 is going to be 69. Okay, nice. Okay. Right? Like you gotta make the idiotic Reddit jokes every time. I don't know. Maybe I don't. Maybe I don't. Sometimes the internet's a bit juvenile. Hey, not like me, of course. I'm extremely mature. Now, where the heck did I put my blue pen? Where the heckarino did that guy get off to? Hold on. I'll crack open another one. A bunch of Bucker 2 pens here. Cracky open. All right, so now we got to find S, right? So we don't know now. We actually don't really. We can't really say that this angle here is the same as T. It looks like maybe we can, right? It kind of looks like we could just look at it and say, oh well, this is 69. So that's got to be 69. But we can't. The reason why we can't say that is because we're actually not told that this line and this line are parallel, right? Since we're not told that those are parallel, we can't go ahead and do that. But there's other things we can do. For example, we know this blue arc, that full blue arc has to be 180, right? We do know that one. So since we know that that full blue arc is 180, and we know what r is, and we know that this is 35, we know that this blue angle, which I'll just call theta now, we know that this one theta is going to equal 180 minus 35, and then minus r. So that's going to be 180 minus 35 is 145. And then r we know is 72, right? So then that's going to be 73 degrees. Once we know that, now we can go on and actually solve for s down here. So we know that s is going to equal 180 minus 35 and minus 73 in this case, right? Because we know that this one here is 73 and this one's 35. So what we end up with then is 73 and 35 is 108. 180 minus 108 is going to be 72 degrees. Right? Oh, obvious. Silly me. Silly me. Of course it's 72, right? It's obvious. Yeah, I could have done this way faster. But hey, teachable moment, right? It shows that there's always loads of different ways to get these ones, because I could have just said, hey, this makes a Z shape and R and S are alternate interior, so R and S have to be equal. Could have said that. Could have, should have, would have. I could have indeed, but I didn't. Right? Whoops. Rip me. Okay. But either way, we could have got there a little bit faster. But hey, as long as it works out in the end, it's going to be totally fine. Okay. And I also wanted to talk about, let's see here. Review sheet 2, number 3. Now, Betty Ann asked about this one specifically. All right, so let's go through and yeah, I'll do both of these ones then. So this one here was assignment. And this one is review sheet. And this is going to be question 3A. Okay, now let's draw the line through here. This diagram that looks vaguely like Pink Floyd album cover. Very vaguely. So that is parallel with this. All right. So now that we know that those two are parallel, right? There's a lot of conclusions that we can draw about these two, right? So we know that this angle in here, this one marked with the black arc, is going to be 8x, so 8 times some number that we don't know. And this one down here, I'll just mark it with another black arc. This one's going to be 3x plus 10, right? But these angles now, say I was to take, say I was to take my diagram, because we're told that these two lines are parallel and that they're lines, let's imagine continuing it over here, right? So if we imagine continuing it a bit further, I think maybe it starts to become a bit more obvious. And maybe I'll continue this part down a bit further too. Right? We don't need to do this. I know it's not part of your diagram, but if these are lines, right? Lines can be continued infinitely. But I really wanted to just show those there. Sorry you're late. No problem. I'm just gonna continue yammering on anyway. And yeah, I mean, I link all this stuff to people after I'm done. So if you can't make it live, that's nothing to worry about. Just being here live allows you to ask me questions as we're going, right? So now with this continued down, I think it's maybe a little bit clearer that um, because these lines are parallel and this is the same line that cuts through both, that this and this, both those sections are equal, right? And if those guys are equal, well then we know then that 8x equals 3x plus 10, right? We can go and subtract 5x equals 10, x equals 2, right? That's relatively straightforward, I think. Um, let's see. The other one you asked about, the one you asked about specifically, I believe, though, was this next one. This next one is a touch more difficult looking, but it's really just the same sort of deal, right? But we do have three variables here, so yeah, they're throwing quite a bit more at us with this question. So let me carry on then. I'm going to do 3b down here. Draw out this diagram. Gotta say, I've had absolute torture the past few days. I've got a song stuck in my head constantly, and I can't get rid of it. It's "The Moon in Your Pocket" by Masters of Reality. And I just keep humming it to myself. And I am paranoid on stream about randomly breaking out into humming notes of it because no one else is hearing the perpetual loop of the chorus in my head like I am, right? So it would just be a little bit out of place. I got x is 25, y is 120, and 2z is 60. Well, I guess that would mean z is 30. Right? Okay. Yeah. Let's see. Let's see if that is correct or not. Yeah, it's a good idea. So now I'm going to get this one down here is 2x plus 10. This one up here is 4x plus 20. And this is a y. And this is a 2z. Excuse me. Oh, those Mr. Noodles that I had for lunch are apparently, maybe they were a bit old. Okay, so there's a lot of different ways that we can go about solving these ones, right? Say, for example, well, we know that y plus 2z has got to be 180, right? But then we have one equation with two variables, so we can't use that off the start. It's important, it's good to know. It will be important eventually, but right from the start, it doesn't actually let us solve the question. But then say we've got this pair of parallel lines, right? So the top and the bottom, these double arrows that are on the top and the bottom, indicate that those lines are parallel with each other. These single arrows that are over here indicate that these are parallel to each other as well. So we know now we know something about these two angles, right? These are, well, both these angles, we know they're going to add together to give us 180 as well, right? And you can see it lots of different ways. But say I was to draw it out like I like to do, and just show how this would continue, right? This is just for diagram purposes. We see here that because these are all parallel, we know that this whole circle corresponds to this whole one. So we know that this angle and this angle are equal. This angle and this angle are equal. So therefore, we know that this angle and this angle add to 180, right? So to figure out the x's, let's see, I'll do that over here in blue then. So we would have 4x plus 20 plus 2x plus 10 is going to equal 180. Right? So now I'm going to go ahead and, of course, combine these guys. 6x plus 30 equals 180. 6x equals 150. So then x is going to equal 150 over 6. Which is going to be 25. That is correct. So x is, yeah, I should have known that off the top of my head, of course. Like 6 quarters make $1.50, right? That shouldn't have been hard. But there it is. Okay, Betty Ann, yeah, checks out so far. Got that one right. Good work. Okay, let's see. Now, how are we going to figure out y and z? Hmm. Hmm. Well, there's a whole bunch of different ways. Like, and the way I'm going to do it maybe is not the same way as the way you did it, but it's going to work. We know that this line and this line are parallel, and so therefore we get two parallel lines and the same line cutting through it. So if that's the case, we know that every angle around this point and every angle around this point have got to be the same, right? So we know that 2z is going to equal 2x plus 10. We could say that right off the start. That's probably not what you did, but we can say that. We also know that 2x plus 10 plus y have got to equal 180. We can say that too, right? There's loads of different things that we can say here. Right, but I'm going to go ahead. I'm going to say I'll do it a little bit differently than probably what you did, but I'm going to go ahead and do 2x plus 10 equals 2z. Yeah, maybe switch it up a bit, right? So we know that 2x is 25, so 2x is 50. So we know that 50 plus 10 is equal to 2z. So then 60 is equal to 2z, or 30 is equal to z. Oh, I am a little bit off the bottom. There we go. It's tough. It's tough to get the camera in the exact right spot to see the full sheet without like getting the table and stuff in the background. Anyway, so there we go. 60 is 2z, 30 equals z, just like what you said, right? Now we also know that this arc that I'm going to draw in green, that full one there has to be 180, right? So we know that 2z plus y equals 180, or 60 plus y equals 180, or y equals 120. So there we go. You got them. Those are all correct. And like there's loads and loads of different ways that we can do these ones, right? But for example, another way is we know this is a quadrilateral with two pairs of parallel sides. If a quadrilateral has two pairs of parallel sides, we know that this angle and this angle are equal, right? So we could say that as well. 4x plus 20 is equal to y. We also know that this one and this one are equal. We know that all four of them add to 360. Loads of different ways we can do it. And we know that 2z is equal to 2x plus 10 because this one is equal to 2x plus 10, and then they're alternate interior. They make a z shape, right? There's loads and loads and loads of different ways of getting these ones in the end. But yeah, you did do those ones correctly, so that's great. Now what I'm going to do, I'm going to pop over and do a few more questions as review for this unit, seeing we're on the topic right now. I've got some from your textbook that I'm going to do, but let me just pop over to my intro screen for a second and remove the starting soon. Then I will go and get, let's see, where's that page that I wanted? Here we go. Okay, document display. Here we are. All right. So this is the chapter self-test for the one you're on, and this is page 116. So this is page 116 in your textbook. I'm going to do a few questions off of this one, and they're a little bit similar to the ones that we just went over. Page 116. Determine the values of A, B, C, and D for those first ones. That's kind of interesting. Yeah, let's do one of those. I'll do 1A for sure. Then if that was useful, we'll do B. But I'll do one from one and one from two at least, and then maybe see about some word problems because those can always be a bit of a pain. Now, this is not the most accurate quadratic I've ever drawn. But, we get there. And then we've got, yes, this is an A. This is a B. This is 70 degrees. 35 degrees. This is C. Well, C is easy to get. In it. It's very easy. Oh, sir. That's very easy, in it. This line is parallel with this line. And then this one parallel with this one. It's either bare easy, right? It could be bare easy. It could be bare safe, right? Basic. Basic. Basic is good. But, schoolwork is never going to be basic, right? But sometimes you're well ash. Oh, sir, you're well ash, innit? Don't mind me. I'm just sort of having a stroke over here slowly. Well, C obviously. C is the third angle in a triangle, so that's a gimme. So that's going to be 180 minus 70 and minus 35, which is 180 minus 105, which is 75. There we go. So we know C is 75. We also know that this is a quadrilateral, right? We can see that it's a yeah. Let's do something a little different. Let's do something a little different to figure this one out. Where this is a quadrilateral with two pairs of parallel sides, there's loads and loads and loads of different things that we can do to get this one. But we know, for example, now if I was to continue this line over across like this, we know that this is now one of the Z shapes that we look for, right? Where there's a parallel line, two parallel lines, and then one crossing in the middle. So we know that this one is going to be the same as C. So this is going to be 75 here as well. We know that. So that's going to allow us to get this little angle in there, right? So we know that little angle now. 70 and 75 are going to make 140. So we know this one here has got to be 35 degrees in there, right? Because all three of those have to make 180. So this is just showing sort of another way that we could go about doing a few of these. We can see that A is 70 because we can take this Z shape, the one that goes like there, there, and then there, and do 70 and A are the same because we also have a parallel line here and here, right? But there's another way we can do it as well, right? We know that this is a quadrilateral with two pairs of parallel sides. A quadrilateral with two pairs is going to have the opposite angles being equal. This one's 35. We know that A has got to be 70. Hey, Slayer Darth. Hey, how's it going? Thanks for dropping by. Just here, doing some properties of angles, some more good geometry. When your boss asks you to do work despite being on furlough, and you'd be thinking, "No, I want to do maths." Great, yeah, that's right. That's the best attitude to have. Always wanting to do math. For me, it's sort of the same, right? When I get contacted to do work, it's math work. Well, actually, when I get contacted by bosses, it's never math work. When I get contacted by bosses, it's always paperwork. When I get contacted by students, it's math work. So obviously, I prefer being contacted by students, right? Because math work is what I'm here to do, right? Okay. Again, right, we know that B and C have got to be equal because they're opposite, and it's a quadrilateral with two pairs of parallel sides. Loads and loads and loads of different ways that we can get that. But we can see pretty clearly, I guess, that B is going to be 75. It's going to be the same as C. It's going to make a 180 with A and this other one over here, right? Like loads and loads and loads of different ways that you're going to get that one. Oh, this is kind of. Oh, actually, no. 1B is a wonderful question. I'm gonna do 1B. Look at that. I didn't realize how good that question was. I'm actually a little bit, yeah, gets a little bit excited about a math question. This is weird. This guy is so strange. He starts rambling and then doing like a Jim Gaffigan impression. I don't understand. Hot Pockets. Again, right? That's no shade against Jim Gaffigan. He's a fine comedian. So maybe a a little bit obsessed with frozen pastries. So here now, we have a quadrilateral. We know that this side and this side are parallel. We know that this side and this side are parallel, right? And then we also know that B is here, C is here, 5A is here, and then 4A is here. So what in the world, like we're not given any angles. How in the world can we find out these angles? Right? There's actually a whole bunch of different ways that we can start approaching these ones. Um, we know that because these are sort of like the inside of a U or a C shape, right? But we know because these are parallel lines, right? If I was to continue it over, like I mentioned doing a lot, like so, we would know that this angle and this angle are equal, which means this angle and this angle add to 180, right? Is B a rhombus? That's a good question, right? So rhombus would mean all sides are the same length, right? So I don't think that we're not really given enough to tell that one. We know it is a parallelogram. Right? So then 4A plus 5A, we know that's got to equal 180 degrees, right? So then we know that 9A is equal to 180, or that A is equal to 20. So now we know that 5A is otherwise 100 degrees, 4A is otherwise 80 degrees, like so, right? Um, we also now know that, that's right, yeah. 5A plus 4A equals 180 is exactly how we would start this one. We can say now that C is 180 and B is 80. 100 and B is 80. We can see that because they're the opposite angles in a parallelogram, right? Which are equal. But there's other ways we could do it as well, keeping with the rules that we've been studying this unit, right? We can see that sort of we make a Z shape here with this with the B and this angle out here, which has to be 80. This one here makes a Z shape as well. Or these are, we know that this one and this one add to 180. This one and this one add to 180. There's loads and loads of different ways that we can go about finding those. But what we'll always get is that B is equal to 80 and C is equal to 100. Right? So sometimes they'll be a bit tricky and give you basically as little information as they possibly can. But there's always going to be some ways to figure out these ones. So let's look at, don't rhombuses tend to be taller than parallelograms? I don't really think that was going to have much to do with it, right? Yeah, because I mean, a rhombus is just it's a shape with 4 equal sides. That's all. For 2b, 130 is on a straight line. That's right. Yeah, so we know that the gap over there is 50, and then because we have x's, all right. So I'll skip. I'll do 2b first. Then I do want to do 2a as well. I like that one. I'll do 2b real quick over here because that one's actually a bit faster. So let's I need like a bigger triangle stencil. The stencil is useful, but the stencil that I have in the middle of this one is a little bit small, so it doesn't come out super well on stream. Okay, so for B here, we know this is 130. Because of that, we then know this has to be 50. We know that, right? And this is 3x, and this is 2x. So since we're given a relationship between the two of them, we know now that 3x plus 2x plus 50 has got to be 180. Number 5 on the review sheet. Okay, yeah, absolutely. I'll get to that one. I'll do 2A next because I want to do that, and then I'll jump back over to the review sheet for you. So 5x is going to equal 130. So x is going to equal 26. Right? So easy enough. So then we found x. So this one here is going to be 326. This is going to be 78. two 26s, so that's going to be 52. Right? There we go. For 2A over here. Yeah, see, there we go again. Just the notes from that chorus. Do 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 do. When the moon falls right out of your pocket. I promise that I won't sing on stream. Actually, like I will save. I will spare your ears my crooning, especially where it'll just be like snippets from the middle of a song that I has become a real earworm for me. No one else is following along with the songs that are playing ad nauseum in my head, fortunately. Right? So now for this guy. Well, this is actually a lot easier than it looks, really. Upon looking more closely at this question, this one's actually fairly straightforward. All this is we know that this plus this has got to be 180, right? Because they're all the three in a triangle. So we're going to have x plus 35 plus 2x plus 50 plus 2x, excuse me, equals 180. X is 19. Okay, yeah, you're gonna get it done. Getting ahead of me. That's fine. So we're gonna do 5x plus 85 equals 180, or 5x's is going to be it's going to be 95. So x then is going to be 18. Yes, right, or 19. Yes, 19. Yes, because 95 because 100 divided by 5 would be 20. So 95 divided by 5 is of course 19. There we go. All right. Those are, yeah. Once you get into those and start getting the rules down, they're not super complicated questions, are they? That's great. So let's see, the review sheet I had mentioned. So let me pop back over to the review and see. Betty Ann, you're asking for number 5, right? Number 5 on the review sheet. Oh no, this is the review sheet, yes. Ah, that's a good question. Find the value of x. Okay, cool. Let's go back over to this display so we can see my sheet a little bigger. This is math. Went through a bunch of geometry yesterday. Yeah, that's it seems like it. Math 2101A, and this is going to be the review. Yeah, geometry like this is always it is fun. I like drawing out the diagrams and stuff as well. So now we have a regular hexagon. Ah, hexagons. I love hexagons. Oh boy. Hex grids. Oh, that's my jam. Like just take hexagons and arrange them in a grid and then, I don't know, randomly generate terrain that's kind of like a real worlds and then play a 4x strategy game on top of it. Oh boy. Isosceles triangle at the top? Yes, indeed. Yes, it is. It is an isosceles triangle because of these marks, like you're saying. Those marks around there indicate that all of those are equal length. Now, I know in mine it doesn't look like it. It does look like mine's taller than it is wide, but never you mind, right? Like I said, we go with the diagram, not with the way it's drawn. We go with the markings on the diagram, the symbols. Since it's regular, all angles must be congruent too. I think I know the answer. Well, sure. Let's have this be a callback to a previous unit, right? Exactly. So we know that the total interior angles of any polygon, is going to be n minus 2 times 180. That's going to get you the total, right? But then, if we divide that by the number of sides, we're going to get the interior angles of a regular polygon, basically. Now I'll use some nerdy math language. That's the interior angles of a regular n-gon, right? What is that? What n-gon? Well, that's just because, like, at a certain point, mathematicians get really annoyed with calling things, hexagons and pentagons and octagons and nonagons and I don't know, decagons, heptagons. I actually said septagon. I said septagon before. You know that? I didn't even call it a heptagon, which is the proper name. Um, but yeah, so at a certain point, mathematicians just get tired of all that like Greek nonsense and just call them n-gons. So this will be a sixgon, right? So for our sixgon here, or hexagon, 6 minus 2 times 180, because that's the number of triangles that it's composed of. Then we're going to divide it by 6. So we're just going to have 4 times 180 over 6, which in this case is going to equal 120. So now, thanks to this, we know that this angle is 120, this angle is 120, this angle, this angle, this angle, and this angle are all also 120 degrees. Okay? Now, we can also figure out what these two angles here are. All right, I'll do the X in blue there, just so we see it. We know that basically now what we have is another small shape, and I'll just draw it over here. I'll just draw it over here just to point out what we're working on for this part. Right? We know that this side and this side are the same, and this is 120 degrees. Right? So we know that because this is an isosceles triangle, these two angles have to be equal, right? So we know this is x, and we know this is also x. So oh boy, I got to try to write more legibly so you can see it on stream. Because the sides are equal length, the angles okay, so the angles at the bottom are indeed equal, right? So this one here and this one here are equal because it's on a straight line. Well, yeah. I mean, it is because it's on a straight line. Yes, it's because this one here goes across on straight. So then we're going to know that exactly. Yeah, each x is going to be 30, right? Because now what we have is 180 is going to equal 120 plus 2x's because there's going to be two of those guys. So 60 is going to equal 2x, or 30 is going to equal x. Okay? But one reason why this is a really good question, right? I love, it's one of my phrases that I say a lot, right? This is a really good question. One of the reasons this is such a good question is because it brings in this other bit from other courses, and you're not necessarily going to be given that. Like you look over here on your review sheet, right? Like, how are you expected to know that when they don't even give it to you? But that's the thing. That's the thing about stuff that was taught in a previous course. Sometimes future courses will just randomly require you to know that bit, even though you hadn't learned it in this unit per se. And, it's still part of the mark scheme to make sure that you remembered how to do that one. Okay? But for here then, like you're saying, what you would do to start it off is realize this is a sixgon, or a hexagon, or a sidmiragon, a civagon. Not that civ is the only thing with a hex grid. Not that civ even had a hex grid for all that long. People forget, man. Hex grids are only in 5 and 6. 4 and previous didn't have hex. Anyway. Underneath the x is a right angle. Yeah, I see what you're saying, Betty Ann. Yeah, that's a good observation. And in this case, it does happen to be a right angle. You're absolutely right. Although with the information that we were given, you don't actually have enough to know that, right? Because in order to be able to use that being a right angle to solve the question, you would have had to have been given this, or some indication that this was a right angle. Even one over here on this side would have been enough. But without it being marked in there, you can't really make that assumption, unfortunately. No, it does happen to be correct though, right? That it is indeed a right angle, and we know that because we found x to be 30, and 120 minus 30 is 90, right? But just from the diagram as drawn, um, you're not told that, right? But if they had this, a right angle indicator there or something like that, then absolutely you could go ahead and solve it that way. And I mean, it is a good eye. Like you're right, it is a 90-degree angle, right? Just excuse me. You got to be careful with teachers being tricksy, right? There was one that I had picked out. There's one that I had picked out that really showed what I'm talking about when I say that teachers are real tricky, and we try to slip students up with diagrams that don't look at all like what the numbers on them represent. But I get what you're saying there. That is a good call for sure. Um, now let's see. Okay, maybe yeah. I'll do one more. I'll do one more on this topic here because I think this one is a decent summary of some of the stuff that we've been doing. Oh, that was a zoom out button. I wanted the zoom in button. Come on now. I'm going to do question 5. Question 5 on this page here because this one's a little bit complicated, looking anyway, but it's a pretty similar fair game to what could be on your test, and it happens to be question 5 again. Look at that. So this is page, what was that? 116. Page 116 in your text. Question 5. So ABCDEFGH is a regular octagon. Boy, all right, this one's going to take a minute to draw. I don't have an octagon that I can use as a stencil, unfortunately. 2, 3, 4, 5, 6, 7, and 8. Well, mine does not look regular at all. It doesn't look regular in the slightest, but we're told that it is. All right? So since we're told that it is, that's what we're going to go with. And this is going to be point A, and I'll call this, oh, we're going counterclockwise. A, B, C, D, E, F, G, and H. Now I'm going to go, there's a line from A to F, like so. And there's a line from B to E, also like so. Okay, draw an exterior angle at vertex C. Determine the measure of the exterior angle you created. Okay, well the exterior angle, I assume what it means is the exterior angle. We're just going to call this, right? Well, to determine the measure of the exterior angle, we're going to go and use the interior angle, aren't we? Right? But to find the interior angle, right, is going to be 8 minus 2 times 180 over 8, which is going to be 6 times 180 divided by 8, and I should know that one off the top of my head, 135 degrees, right? So if this is 135, we know that the red one over here has got to be 360 minus 135, so that one there has got to be 225, right? So prove that AF is parallel to BE. How are we going to do that? Well, there's a bunch of ways that we can do that. Like kind of like everything that I'm saying here. We know that this is 135 and this is 135, right? So then we can actually figure out the measure of this and this. Because we know that these have got to be equal. We know that these have got to be equal because all these sides are equal length. This one is cutting across. This is cutting across, but it's all these sides are equal, and this is the same sort of side extending across. All the exterior angles of a regular polygon equal 360. Well, yeah, sure. Then what we're meaning? Oh, okay. I see what you're meaning by exterior angle. Yes. So then we're going to go 360 over 8 and get 45. Right. Yes, because that 45. Oh, yes. Yeah, I was saying exterior angle as being the rest of it, but no, you're right. You're right. Exterior angle is when we take our line, say one of the ones here, and then continue it over like so. Right? So then this exterior angle is that part there that causes it to add up to, it causes this add up to 180. But also, yes, we can do 360 divided by 8 and get 45. So the black angle that's in here is 45 degrees. So that's the angle formed when we continue one of these lines on, right? So if we took this line here that was by E and continued it on this way, right, we would know that the exterior angle, or this part here, is going to be a 45 degrees. They're like so, right? We know that that one is 45. If we continued this on out here, this here would be 45, right? So you can think of, you can think of exterior angles kind of like, if it was a saw or something like that, and it had these sort of teeth extending out on either side. So this one here is going to be 45. This one's going to be 45, right? But you're right, yes. I'll write that down over here. Right? Okay. So now there's a bunch of different ways that we can go about finding these ones, like I was saying. One way that I was thinking of is we know that this shape down here, even though it's a bit oddly shaped, it's still a quadrilateral, right? We know that this interior angle is 135, this interior angle is 135, and we know that because all these measures are equal, this angle and that angle have got to be the same. So there's going to be 90 degrees left over to split between these two guys, or we know that both those guys are going to be 45. There are other ways, of course, to determine this as well, but we can't. We have to be careful in our determining that we're not assuming that these guys are parallel, right? If we assumed these guys were parallel, we could say continue it out here and get like a Z shape with this one and the bottom one down there, right? But BCDE is a quadrilateral. So we know that three of those sides are equal, and that one there is not. So we know then that, say, this is going to be angle x, and this is going to be angle x. So then we could say that 360 is equal to x plus 135 plus 135, or 360 is equal to 2x plus 270, right? Which gets us 90 is equal to 2x, and 45 is equal to x, right? We could say that. Yeah, because we don't actually know. We're trying to prove that AF is parallel to BE, right? So we know that this is 45 and this is 45. We then know, say, that this full red bit here, we know that that one is 180, right? So that's going to be this one theta. So then theta is going to equal 180 minus 45 and minus 45, or theta there is going to equal 90. Right? Once we've got this one as 90, we can do the same thing to find that this one is 90, the same thing up here to find that this one is 90, and the same thing to find that this one is 90. Because the angles are the same, those two lines had to be parallel. Yeah, this one's a lot more complicated than what you're going to see on your test. I'll tell you that. I'll tell you that straight up. That this here, and then for the same reason, we could find this one over here to be 90 because of our exterior angle, say that's going through like so, right? We could also say that, yeah, we know that x has got to be the same as an exterior angle, right? But yeah, there are a lot of different ways that we can go about this one here. I did want to point it out a bit because it does bring up stuff from a previous chapter. But yeah, Betty Ann, you don't really need you don't really need to worry about one getting quite this complicated. Although, you know, it is important to remember these few other rules, right? The interior angle, you might be asked for the exterior angle, might be asked to remember that a quadrilateral makes 360, and so on, right? But yeah, I don't think you were intending to. All right, yeah, tomorrow's not a day you can do tests anyway. Yeah, if you're intending to do your test for Tuesday, do let me know. But you'll have plenty of opportunity to ask me more review questions before then. How I proved AF and BE are parallel. Right, okay. So basically what we've got to do is we've got to prove that we're proving that theta here is 90, right? The way I proved that theta there was 90 is that I knew these two angles were equal because we've got those three equal, because this is a regular polygon, right? So we know that this angle and this angle are equal, and both those are 135. And then because it's just the one bisector coming across here, we know that this angle and this angle are going to have to be equal as well, right? These two x's. We know that x and 135 and 135 are going to make 360, right? So then once we've got that down, I figured out that x was 45. And that's not the only way of doing that, but that is a way of doing that. We also know that, say, if we continued, say, this line here past point E, if we continued that past, we would know that we know that our exterior angles are 45 anyway, right? This one here is a 45, and this one here is a 45. So then we know that this whole red arc, this whole thing here has to be 180, which means this angle here is going to have to be 90. And we can do the same thing down here, for example, like an exterior angle past point B. This one here has got to be 45. Or another way, actually, hold on. I've just really convoluted this, haven't I? I've made this a lot more convoluted than it really needs to be. A lot more convoluted than it needs to be. So let me just recap something here that maybe is a heck of a lot easier. Say we took both these lines here and continued them out. Okay? This is a way easier way to do it. I don't know why I just did a more complicated way, but whatever. We know that this black arc here, we know that one's going to be 45. Right? This other arc here, this one's going to be a 45 as well. Right? So now we've got this is 45 and this is 45. But we know now that, say, this is a straight line. So if this is 45, this one here has got to be, so basically we've got like an X here where two parts are crossing each other. So this full part inside, excuse me, this one here has got to be 135. This one inside here has got to be 135 as well, right? Then if we sort of continued this one out here, right, we would know that this is 45 and this is 45. If all of these ones around here make 45, we got to know that this is going to have, these ones across are going to be equal to 90s. Just because of the, you know, the way that those intersect there. I mean, my goodness, it got a bit more complicated than it needed to be, because of the way that was drawn. But yeah, I think that's a fine answer for that one. But you know, I didn't really prep an answer for that one beforehand, so it might not have been the easiest way to do that. But anything you do to figure out those, as long as it's logically consistent with the rules that you have, it's going to be totally fine. So I want to pop back over to my intro screen for a second. For Math 3102B, I mentioned that I'm going to go over how to calculate loan payments with online calculators. So Esther, you will see when you go to your 3102B study guide, you're going to see this sort of page here, right? So here's one of the early pages of your study guide. Test papers I use freely available. No, those aren't. Because whenever I make up a new one, it's a fair bit of extra work for me to go through and make up a new one and make up a new answer key and all that kind of stuff, right? yeah, our testing materials actually aren't in the program. The study guides kind of are. The topics that our study guides cover are publicly available, but the guides themselves are not. Um, I do think though that the publicly available past papers, like you mentioned before, are a great idea to use for these ones, right? Um, so Esther, yes, this is the first page of your guide, and you will notice down through here, it starts showing you some stuff to use in a calculator, right? Like this whole section here, right? Now that, if I was to bring up my calculator here, notice how similar it is. I'm gonna go over here to apps. I'm gonna go to finance, TVM solver, and here it is. Look, there's the program. Unfortunately, you probably don't have a TI-84 at home or 83, and we're definitely not going to be about, making you go get one of these. I mean, these still run like, I don't know, like 150 bucks or something foolish, even though they're like 15 years old. And you could get an emulator that runs it. One of my students before had like an iPad emulator that just ran the entire calculator with the whole, like, with all the buttons there on touchscreen, which is very, very useful. But you don't have to do any of that. You don't have to introduce yourself to, like, you know, uh, I don't know, homebrewed emulators for calculators and stuff. Not going to require you to go on the piratebay.org and start downloading random programs to see if they work. No, not that I would discourage you. No, no, I would discourage you from doing that. But what I'm going to show you instead is going to be this. Here we go. So this is a calculator that I found from CCH websites. Um, the site, well, I'm not affiliated with the site in any way. It's not, the site is nothing special. I just found this one that happens to have a lot of the features that we're going to need for this course. One of the main problems with going online and just sort of Googling mortgage or loan calculator is that a lot of the time when you do that, it's just a thinly veiled ad for whatever bank or lender supports it, right? And a lot of them don't have the features that we need. I'm going to send you the link to this one because this one does have the features that we need. And what are those features? Well, I'm going to zoom in actually using Chrome here now. Look at this. Look at this technology. Whoa. All right. So that loan, that's not a loan that I have in real life. That was just an example from the book that I was trying to see if I can get a some good solutions for it here. But this is the calculator that I'm going to recommend you use for now. Partly because, well, it has this nice handy graph that it comes up with too. But it allows us to change all the different things that we are going to need to change in the course, right? So whenever it comes up with questions saying, with parts in the study guide, telling you how to go and learn how to use a TI-84, like this one does down through here, we are instead going to use that website that I will link you shortly after this video is over. But if you look down here, let me just zoom in. I'm going to briefly explain what each of these parts means, so then you can see how to go ahead and put it into the online calculator that I'm going to link you. Now, Esther, if you're not onto this one yet, no big deal. I mean, you just received this guide today. I'm not exactly expecting you to run out and go looking down through it immediately. Excuse me. But I am going to explain basically what these different sections stand for. Right, so we have, I'm just going to draw out a little diagram of what the screen would look like. So we've got n equals 48. I'm going to do some of these in different colors. I percent equals 2.9. We've got PV is going to equal 8605. We've got PMT equals this negative 190.08580 and so on. Right? And then we've got FV equals 0, P over Y equals 12, and C over Y equals 12. Now, I'm going to tell you right now, don't really need to you don't need to worry about these last three. I know it's a bit weird to start off talking about the last three, but the calculator that I'm showing you online doesn't actually have the ability, doesn't actually have the part on there to change a lot of those, but that's totally fine, right? I think in this course you'll be able to do monthly. I think they will ask you to do monthly amortization, right? But FV means future value. Um, for this course, FV will equal 0. Okay, so again, you don't really need to know the FV part, the future value. In your calculator, what that allows you to do is instead of having a loan that you're paying off, you can instead have a investment that you're trying to grow, for example, or a loan that you want to get down to half the amount. Your calculator is able to do that. The online one that I'm going to show you can't do that part. The online one only goes to 0. What future value of 0 means is that's paying off a loan in full, right? So in your calculator, when you leave it as a future value of 0, that means you're asking the calculator to find how long it's going to take to pay the loan off entirely. So the online calculator is going to set FV to be 0 all the time. In the online calculator, FV equals 0 always. Okay, so you don't need to worry about that. P per Y is equal to payments per year. This online calculator that I'm going to link you to use always does 12 or monthly, right? So you're not going to need to know about that because you're not going to have to be having to switch that around at any point. And C per Y is equal to compounds or compounding periods. So for this one, set amortization to monthly, right? And that's all you're going to need to do. Right, so these ones are a little bit of an aside because I know I'm getting to those first, which maybe seems a little bit weird to do those first when it's not what you're going to need to be worried about first. But I wanted to go over those to get them out of the way because those are less important than what we're going to be getting onto here, right? So when you're doing this calculator on here, you'll see it says calculate for monthly payment, interest rate, term, and oh, you can't actually, again, you can't see on OBS when it's a tooltip. Oh, that's a little annoying actually. Okay, if you click here, you'll get a drop-down menu that allows you to change which one you're looking for. Most of the time, you're going to be looking for monthly payment, almost all the time. So you're generally going to be leaving this top one alone like it is, okay? When we go back over to this one here, you'll see N is equal to 48. N is the number of payments. Okay, so for this first one, N equals 48, and P per Y was 12 in your book, right? So there were 12 payments per year, 48 payments. Clearly, those are monthly payments, right? So it's a 4-year loan. right? Usually in this course, it's going to be years times 12 or monthly. In the real world is usually not. Real world is usually, hold up, hold up. I am holding. Manguato? Moniguato. I am indeed holding up. Uh, but yeah, so their N would be the number of payments. Usually it's going to be 12. Is that the real NL Math Man? Yes. The one and only. Um, some often imitated. No, rarely rarely imitated. But yes, I am real. I think. I mean, I I guess I have no guarantee that I'm real. I could be a simulation. I'm not entirely sure. Okay, now you've now you're really drawing my entire reality into question. I'm not sure anymore. Maybe I'm not real. Okay, I mean I guess my senses are not really any guarantee, are they? I think I'm real. The coolest mathematician of all time. That's right. Yeah. Oh, well, you've heard of me. I am indeed the coolest top ranked math master. No, actually, I was recently dethroned by by ON Math Mam, right? But you know, we'll get that title back one day. So the interest rate percent is 2.9, right? So this is just so I he doesn't deserve it. Well, it's a she, right? It's ON Math Mam instead of Math Man. But you know, I mean, we do what we can, and you know, Ontario needs maybe could use a little bit of a bump right now, right? So I'm going to let them have it for the time being, right? But you know, we'll take it back. We'll take it back once the dust all settles, you know. But I figure they need a little bit of a boost right now. Something to pick up the spirits. So I is the interest rate as a percent, right? There is only one math man. That's true. Yeah, I guess. But I mean, the fact that I had to put two letters in front of my name actually to specify which math man I was, you know, maybe there are more than one, right? I'm not. Is this like a Final Fantasy VII thing? Was I a was I a clone soldier in the Math Wars, right? Or maybe it's like Mega Man. Actually, I made that reference before as well, right? Maybe the Doctor Math made me in order to you know make terrible jokes about geometry. Don't forget to stay frosty, you wonderful mathological masterpiece. Oh, great! That's yeah. I mean, you can cause a disturbance to say things like that all the time. That's that's wonderful. Thank you. I am staying frosty. Mm-hmm. Although, I mean, we had frost only a few nights ago, I think, right? Like it's down below zero in the night sometimes. Still, that's spring. It's spring in Newfoundland for you. So PV is going to be the previous value, right? Or the PV is the previous value, or that is how much was borrowed, right? So again, the calculator is able to do investments as well, like because they kind of work the same way. But the calculator that I'm linking you to online just does loans. So here, your PV is going to be the amount borrowed, right? And then PMT, I mean, as you could guess, is simply going to be the payment. And I believe for this course, I believe all of them are monthly payments. I might be wrong about that. If you come into a question that asks for something other than monthly, tell me, and I'll find a different calculator for you to use. But um, as far as I remember, all of them are monthly. Now, the reason on here they have a negative is again, right, because this program can do investments versus and loan payments. So they have a negative payment to make it clear that you are giving someone away your money. And if you were earning money on an investment, that would be, a positive 190 there. Although, I mean, I'd like to see a 3% per year increase on investments. That'd be stellar. That'd be fantastic. That's beating out inflation by an entire percent. I mean, it sounds like I'm joking, but I'm not. That'd be wonderful. Um, anyway, let's go back over. Oh, wrong one, wrong one. Chrome. Here we go. So if I was to take, oh, I'm gonna need to switch around my scenes a little bit here because I need to have my paper. Need to have my paper up as well. Here we go. Got them. All right. So it's a little bit difficult to see it there. Maybe yeah, there we go. Increase the size of that guy a touch. Okay, so let's plug these numbers that we were given in this example into this calculator, just so you can see how to do it, right? So the loan amount that we were given, let me grab my keyboard, sliding on across there in front. I don't have a ton of space for this setup, right? I don't have like a room in my house for teaching. If I had you know, if I knew when I bought my house that I was going to be distance teaching, maybe I would have. But, live in a small apartment beneath a larger apartment that I rent. So don't really have a whole lot of spare rooms to use as an office. I've just got the one like nerd room, which I call my office, but usually the sort of office work I'm doing is capturing flags and winning team fights by healing everybody. Well, let me tell you, when Azo rolls into an AV game, you're gonna win some team fights. Let me tell you, I there's not many things I do better than raid healing in World of Warcraft. Let me tell you. I've got maybe more practice than a lot of people. I've got an embarrassingly large amount of practice. Anyway, don't want to, but strictly in like the low effort ones, like the low commitment ones, like an Alterac Valley game. Anyway, where did I even get off onto this topic from? Right, talking about the rooms in my house. I don't have a lot of room to move my keyboard around, is what I'm saying. Anyway, Esther, sorry that I'm rambling again, but you're used to that. You've been in class with me before. So the loan amount, 8605. So that's just the amount that we had right here, 8605. The interest rate, then, 2.9%. So let me just find where the heck my cursor is. 2.9%. There we go. It automatically pops in percent. Term in months, 48. Hey, look, it's already got it. Look at that. Did it. Did it already. Now, notice if I go amortization monthly, that's going to change. No, it didn't change at all, did it? No. Okay. Oh, that's handy. Look at that. You can even click on there and it comes up number of months for this loan, monthly payment for this loan, annual interest rate. Okay. Okay, pretty nice. Total amount. And you see there, it matches up with what we were told. Right? Another neat thing that you can do with this calculator, that say the one in your, if you're using a TI-83, the one that couldn't, you can actually say mouse over this. Oh, now my tooltips are showing up. What the heck? What the heck, OBS? Oh, this one's not though. Oh, this drop-down menus that don't? Boy, I got a thing or two to learn about OBS still, obviously. Probably a thing or 100. But you can scroll on over this and you can see after so many months what your new balance is going to be, right? So you can see, you see how many payments, how much you're paying off the loan, right? But as you see here, the calculator came up with 190, exactly the same as the notes did, as the calculator did in there, right? So when you have to do any of these, you'll use this calculator. And like I said, when I very shortly. Now Esther, I'm going to send you an email with this in it. So yeah, I don't know if you're watching live, but you will be watching in the future, I guess. So let me know if you have any questions about how to use this calculator. I tried to find one that was a good balance between having all the functions we need and then not having like hundreds of other functions that we don't need, and tried to find one that wasn't just a ad for a bank, right? But anyway, like I said, I'm not really endorsing this page so much as it's an effective thing for doing what we need. Okay, so I think that should be a decent look at all the topics that I needed to get to today. Thanks for hanging out and being with me there for another afternoon of math. I hope you found it useful. Uh, Rocking the sweater today? Yeah, absolutely. I rock the sweater every day. I'm except for Fridays sometimes. Sometimes I don't. I've got a Mr. Rogers sort of wardrobe, right? You gotta have sweaters and cardigans, right? It's good. It's practical. It's all season apparel. Is what I'm saying. It does get a bit warm in the summer sometimes, but you know there's air conditioning for a reason, right? Keep up the good work. Well, thank you. Thanks very much. I'm glad you're enjoying it. Thanks for dropping by. Said I am just cluing up for the day here now. I have other other of my teacherly duties to go get to. But yeah, thanks for dropping by, Alf 000. And yeah, hope you stay safe out there, and I'll be back again tomorrow. So I hope to see you there.